Ladies and gentlemen, please remain in your seats as we welcome our guest of honor, Minister of State for the Ministry of Culture, Community and Youth and Ministry of Trade and Industry, Mr. Alvin Tan. Good morning, ladies and gentlemen, and a very warm welcome to the Global Additive Manufacturing Summit. My name is Lorene, and it is my pleasure to be your MC for this event. The Global AM Summit is the flagship event of the National Additive Manufacturing Innovation Cluster, where we gather global thought leaders, entrepreneurs, and leading application experts all in one place to explore the coming trends and directions of the AM sector. Now, this year's summit, Digital Transformation with Additive Manufacturing for a Sustainable Future, will explore various topics including AM strategies, sustainability, aerospace, artificial intelligence, and digital workflow in AM over the course of 2 days. And along with that, we will also bring forth 4 partnerships and alliances that will propel the use of AM in industries to strengthen our collective capabilities. So without further ado, to kickstart this year's summit, I'd like to welcome Chief Executive Officer of NAMIC, Dr. Ho Chaw Sing, up on stage to deliver the welcome address. Dr. Ho, please.
Mr. Alvin Tan, Minister of State, Minister of Culture, Ministry of Culture, Community and Youth, and the Ministry of Trade and Industry, Professor Tan Cho Chuan, Chairman A*STAR, Your Excellencies, distinguished speakers, guests, friends, partners, and colleagues, ladies and gentlemen. A very good morning, and on behalf of the organizing committee, it is with tremendous pleasure that I welcome all of you to the NAMIC Global AM Summit 2024. This summit, our 13th user-focused Global Additive Manufacturing Expert Forum, focuses on the theme, digital transformation with additive manufacturing for a sustainable future. It is a timely one given the rapid emergence of Gen AI and obviously several challenges that we're now seeing across the globe, notwithstanding the need for us, humanity, to address climate change through reducing greenhouse emissions and scaling decarbonization initiatives. Now, additive manufacturing technologies are rapidly transforming industries with its flexibility through digitalization and automation in fabrication processes, and the unique features of additive beyond reducing production lead time and material waste, design customization, and the limited use of tooling as compared to conventional manufacturing is its digital nature and provides a tremendous opportunity for enterprises to shift towards a more data-driven approach in both design and production and optimization supporting the sustainability. For countries like Singapore with limited natural resource, it cuts across several industries and serves to enhance our supply chain resilience, enable innovation, and is key to grow and develop our deep tech enterprise ecosystem. We're very honored and pleased to have with us today several partners, global thought leaders, and friends from the global and local AM community. They represent the entire technology value chain, including metal foundries, recycling companies, software in artificial intelligence, generative design, and digital workflows, hardware platforms, as well as enterprises in clean energy, aerospace, space, and micro-optics. Our speakers today will explore and share about the convergence of AM and digital transformation and how they can be harnessed to enable a more sustainable future. Now, in spite of the increased geopolitical and technology bifurcation, there's no doubt that we all live in a global village with complex interdependencies among nations and people. Sustainability in development and manufacturing is a common humanity goal that we all need to embrace and work together to achieve. Businesses, whether in consumer, transport, healthcare, construction, industrial, or in new emerging industries such as clean tech, will need to stay adaptable and nimble through the adoption of new technologies and to reskill the talent pool. Our current and next generation of engineers will need to adapt, reskill, and be equipped with the tools and knowledge of which additive manufacturing is central to solve the increasingly complex problems in the world. Technologies such as artificial intelligence, robotics, and additive manufacturing will increasingly play a pivotal role in enabling some of the new paradigms in digital and on-demand distributed manufacturing, enabled by intelligent systems and automation in processes. On this note, I would like to take the opportunity to thank again all our speakers who have taken valuable time out of their busy schedule to be here with us in person, several of whom have flown to Singapore just for this event. Thank you very much for that. We're also very pleased to have the strong partnership from Constella and Deutsche Messe to host this event in conjunction with ITAP 2024. ITAP is Asia's Pacific leading advanced manufacturing event and was launched yesterday by Deputy Prime Minister Heng Swee Keat with the theme Shaping the Future with Sustainable Manufacturing, featuring more than 400 exhibiting brands, 9 regional platforms, and 3 industry-led pavilions, including the AM Startup Pavilion. I will highly recommend all of you to visit in between the breaks. Finally, I want to take this opportunity to thank the wonderful team behind this event, the entire NAMIC team, together with our colleagues from A-Star, partners from Advocate and their associates, who have supported and worked tireless with us to put all this together. I also like to make a special mention of all our university, polytechnic, A-Star Additive Innovation Center cluster teams, as well as industry partners who have partnered with us to put together the wonderful program that we have today. I encourage all of you to reach out to the speakers and interact with your fellow participants and hope that you will benefit from the content we have put together. I wish you all a very fruitful and productive summit ahead. Please enjoy the show. Thank you very much.
Thank you, Dr. Ho. Now up next, it is my pleasure to invite up on stage our guest of honor, Minister of State for the Ministry of Culture, Community and Youth, and the Ministry of Trade and Industry, Mr. Alvin Tan. Minister, please.
Morning, everyone. Professor Tan Cho Chuan, Chairman A-Star, Dr. Ho Cho Sing, CEO of NAMIC. Ladies and gentlemen, good morning to all of you. I was just joking with Dr. Ho that, in fact, today is a very busy day. We have about 3 days of Parliament, and I was just double-checking that I have my correct speech on my teleprompter app. In case I say anything that's suited for Parliament, then please correct me. But today, I still remember we were here just last year, so 1 year has flown, and I'm really glad to see Paul here also, bringing together ITAP and NAMIC. I think these are really good showcases of our ecosystem and what we're trying to do in the manufacturing sector, but also precision engineering, precision manufacturing, and of course, very importantly, the AM sector. Now, last year I spoke about how we continued this. Hang on, just 1 second. There's a lot of echoes, right? Is that okay? All right, okay, let me restart this a little bit. As I was mentioning, last year I spoke about how we continue to see a strong growth trend for our AM sector. And I also encourage companies to adopt AM so that we can spur sustainability journeys, supply chain resilience, and also spur innovation, the innovation that Dr. Ho was talking about earlier on. Now, our sector continues to grow strongly. If you think about the global AM market, it grew about 11% in 2023 and is projected to reach over 53 billion Singapore dollars by 2028. So it is a growing sector. All of us are here. All of us are very optimistic. But how then can we add to this AM sector, and how can we grow our AM sector? And today, this morning, please allow me to suggest 3 ways. First is to grow it green. Second is to grow it with AI. And third is to grow it with partnerships. So to grow green, to grow with AI, and then to grow with partnerships. And our AM sector is the perfect sector to grow green. It's a perfect sector to grow green. Why? Because of its nature, its precise nature. AM, as you all know, uses less materials and less energy compared with traditional manufacturing. It is, in all sense of the word, on demand. So you can print your materials faster and closer to where you need it and when you need it. Uses less material, it uses less energy, and ergo it also uses less transportation because it's when you want it and also where you want it. At the same time, we can also use recycled and sustainable materials in our AM processes. And there are companies like Continuum, a metal powder manufacturer, that recycles metal and secondary raw materials both locally and also sustainably. This morning, we will witness a key milestone for Madarium, a 3D printing service provider. Madarium will launch its ISO 13485 certified 3D printing facility for medical products and custom food orthotics. Now, this is an example of both efficient and also sustainable manufacturing. I think we saw some of these companies last year at NAMIC, even creating stuff for casts, traditional casts, and also for babies. Now, Madarium's printing facility enables local clinics and hospitals to treat their patients faster and more effectively without having to then go overseas to source for these products. This is beneficial because it could reduce turnaround time from an average about 2 weeks to 5 days, and even within 24 hours for more urgent cases. This is a great example of how growing green can make a meaningful impact on the ground. In addition to growing green, our AM companies are also growing with AI, or artificial intelligence. Now, companies can use generative design algorithms to create efficient and geometrically complex designs. They can do so by optimizing the shapes, factoring the strength, weight, and material that they need for a specific project. Companies can also use AI to analyze massive data sets of materials, properties, and behavior so that they can recommend the best one in terms of strength, in terms of durability, and also in terms of cost efficiency. This can then help them to discover new material combinations faster and combinations that optimizes the use of recycled or sustainable materials. And this improves the performance and environmental sustainability of manufactured products. Again, very different from traditional manufacturing. And we have a good example of this. A company that's doing this is software company Hyperganic, which is here with us today. Can I see where Hyperganic is? You are here with us, or they're still doing additive manufacturing? Okay, good. Well, Hyperganic specializes in designing complex and highly optimized geometrics using algorithmic engineering. And during tomorrow's AI session, firms that have incorporated AI into their processes, like Hyperganic, will share insights to give all of us here, delegates, a deeper understanding of how they are deploying the use of AI effectively and efficiently. And I hope their insights and insights of others that are deploying AI will encourage more companies to integrate AI into your additive manufacturing process. So to better grow green and to better also grow with AI, I think we also need to then grow our partnerships, which is exactly why we have this event, especially why we have ITAP. Last year, I announced the launch of NAMIC's Digital Design Innovation Center, which will be located within the Jurong Innovation District, or JID. This center will help companies kickstart the additive manufacturing journey. So we're helping you to kickstart this if you've not already been on this journey. But today, please let me share 4 partnerships that are helping to grow our AM sector. First, there's AM service provider JSSB. JSSB is partnering NAMIC to create an inventory of digital parts that will be fabricated here in Singapore. These parts will be used in the oil and gas sector for end users such as Petronas to ensure the continued operability of their assets. NAMIC will also co-fund the development of AM-ready digital parts. This will help our local small and medium enterprises to overcome cost and knowledge barriers to adopt AM and digital inventory solutions. So that's the first partnership. The second partnership is between the American Society of Mechanical Engineers and Skills Future Singapore. This is with regards to talent development. They will partner NAMIC to review the National Additive Manufacturing Job Skills Accreditation Framework. Now, this framework, and within this particular National Additive Manufacturing Skills Accreditation Framework, it's a long acronym. Within this framework, we will have AM courses. AM courses will be supported by Skills Future Singapore, which will be organized into different proficiency levels for specific additive manufacturing jobs. And this framework will also guide the development of new courses to plug knowledge gaps where they identify knowledge gaps. And it's important for industry to help us to identify these knowledge gaps so that we can then build that into the courses and for them to then grow both their courses and also their skills and abilities. For aspiring AM professionals, this will ensure that they receive holistic and recognized training that is aligned with industry needs. So we're not doing it in isolation, but together with industry. Then third, you have manufacturer INGTech and NAMIC. INGTech and NAMIC will set up a technology center of excellence in Singapore. The center will support the development of new AM competencies and capabilities in automotive, semiconductor, and life sciences industries, empowering AM professionals in the process. Now, as part of INGTech's domiciliation in Singapore, this partnership taps on INGTech's expertise in die casting and precision machining, and also Singapore's position as the region's AM hub. And we had discussed this earlier this morning. Finally, the fourth example of a good partnership that we're growing is between the Maritime and Port Authority of Singapore, MPA, and NAMIC, which has launched Phase 3 of the Maritime AM Joint Industry Program, or JIP. Now, JIP aims to encourage AM for maritime applications. And Phase 3 of this program will bring together consortiums comprising maritime and tech players to advance the use of AM in maritime parts and marine parts. This is important because this will then in turn scale the adoption on board ships and harbor crafts, and it will enhance the resilience of the parts supply chain. It will also promote cradle-to-cradle manufacturing among local manufacturers and also contribute to the development of greener vessels. In fact, we see a lot of these hybrid and green vessels already being designed, developed, and manufactured in Singapore. Now, these proposals submitted by interested consortia have shown great potential, and we look forward to announcing the successful consortiums in due course. So, ladies and gentlemen, thank you once again for having me here at NAMIC. Thank you to the team behind the scenes for putting together this very important initiative. Thank you once again for turning up here at the Global Additive Manufacturing Summit. And again, please allow us to all continue to grow our AM sector together by growing green, growing with the AI, and also growing with partnerships. Thank you very, very much.
Thank you, Minister. Please remain on stage. Now, on this note, we are excited to move into our next segment, where we will review the 4 partnerships and alliances to strengthen AM capabilities in Singapore. Firstly, we are excited, or I'm also very excited, to announce the launch of Maderium's ISO 13485 certified 3D printing facility for medical products and orthotics manufacturing. To join Minister on stage for the launch, may I please invite Mr. Miles Podmore, Board Director of Maderium, Mr. Nero, General Manager of Maderium, Dr. Ho Chaw Sing, Chief Executive Officer of NAMIC, Professor Tan Cho Chuan, Chairman of A-STAR, and Dr. Sidney Yee, Governing Board Member of NAMIC. Ladies and gentlemen, a round of applause. Now, with this partnership, we will have the first ISO certified 3D printing facility for medical products and custom food orthotics in Singapore, benefiting the local healthcare and podiatry sector to enable better patient outcomes. And we'll just hold on for a while while we present the scissors for the ribbon cutting ceremony. Now, as a health science undergrad under the support of Madarium doing 3D printing, I'm particularly excited to see this facility myself. All right, to officially launch the Madarium and Singapore's first ISO certified medical 3D printing facility, we'll now have the ribbon cutting ceremony. But before we do that, we'd like to invite our launch party first for a photo holding the ribbon bow in your left hand. Big white smiles for our photographer. All right, now on the count of 3, we would like to invite the launch party to cut the ribbons on both sides. And of course, ladies and gentlemen, please join me in the countdown as well. So let's get ready in 3, 1, let's cut it. Congratulations on the launch. I don't think we are going to throw it, but we can hold it for a picture together. Congratulations once again. Now, assuming everybody still has a ribbon bow, can I invite the launch party for a photo together? Thank you, ladies and gentlemen. We invite you back to your seats. Thank you very much. Now, just to share a little bit more, I'm actually personally under the tutelage of Niro and Nazrul, doing medical 3D printing. So thank you very much. Now, as our guests proceed back to their seat, we'd just like to get everyone ready for the next part. Now, to introduce Singapore's first ISO certified medical 3D printing facility, ladies and gentlemen, your attention to the screen.
In a world where one size rarely fits all, personalized healthcare is not just an option, it's a necessity. At Madarium, we shape the future of healthcare by integrating advanced 3D printing into the solutions we provide. Our technologies empower professionals to offer faster, more accurate treatments, ensuring every solution fits the unique needs of each patient. We address the unique challenges of the healthcare industry by providing expertise and solutions in the following areas: customized anatomical models and cutting guides, production of key medical supplies, and enhanced training for healthcare professionals. During the COVID pandemic, we worked with partners and medical practitioners to design, clinical trial, and produce millions of COVID-19 swabs in order to reduce potential shortages created by the pandemic. Quality is at the heart of everything we do. To ensure we meet the highest requirements of the medical industry, our manufacturing is now certified to the internationally recognized ISO 13485 standard. This ensures the products we produce are safe, reliable, are of the highest quality, and can be trusted to provide the functionality needed. We have recently embarked on a new chapter to provide the same level of quality and commitment to the orthotics industry. Combining cutting-edge 3D printing technologies like SLS, SLA, and FDM with precise CNC milling, we are now delivering custom insoles from start to finish and working with podiatrists to bring solutions to improve patient care locally and regionally. At Madarium, making a positive impact on people's lives is at the heart of what we do.
Ladies and gentlemen, once again, that was Madarium. I'm sure they will go on to make positive impact in people's life. Can we give them another round of applause? Now, and following the launch, we would like to announce 3 alliances with the signing of MOUs. Now, the first between Ing Technology International Private Limited and the National Additive Manufacturing Innovation Cluster. With the establishment of the AM Technology Center of Excellence, this partnership will enable the training and upskilling of AM talents, the advancement of industrial research and development to expand market opportunities of AM in Singapore. Now, to take a look at the exciting partnership between IngTech and NAMIC, ladies and gentlemen, please join me in watching the next video.
We are delighted to sign a Memorandum of Understanding between NAMIC and IngTech.
As the national platform for additive manufacturing, NAMIC is excited to enter into a partnership with IngTech.
This collaboration will create significant value as we work in partnership to establish an additive manufacturing technology center of excellence in Singapore.
Our collaboration aims to develop and customize advanced additive manufacturing training courses, leveraging NAMIC's accredited service providers to ensure the highest quality of education and upskillings.
We're committed to help companies develop new capabilities, equip our professionals with industry-relevant skills, and position regional enterprises like IngTech to leverage on Singapore's expertise in additive manufacturing.
Through the Innovation and Enterprise Fellowships programs, we will elevate IngTech's technical and operational expertise. We are committed to exploring future industry applications of additive manufacturing technologies in sectors such as automotives, semiconductor, HVAC, and life science equipments. Our material research will focus on optimizing and testing specialized aluminum alloys, while our efforts in process optimization and automation will enhance post-processing technologies, including high-precision machining, coating, and automated assembly. We will deploy additive manufacturing machines and capabilities within IngTech to facilitate the commercialization of advanced manufacturing technology in the region.
The new Center of Excellence will bring us closer to our vision of establishing Singapore as a deep tech innovation hub where additive manufacturing is a key enabling technology for sustainable manufacturing.
We are confident that this center will serve as a beacon of innovation and excellence, driving advancements in additive manufacturing technology across the region. This partnership will drive innovation and support IngTech in expanding our market reach with additive manufacturing. Together, we will build a future where additive manufacturing technology transforms industries and propels us towards new horizon of success.
Ladies and gentlemen, it is time now towards a new horizon of success. So with that, it is my pleasure to invite on stage for this MOU our signatories, Dr. Teck Yong Kun, Chief Executive Officer of IngTech, and Dr. Ho Chor Sing, CEO of NAMIC. And of course, joining them on stage, please also welcome our witnesses, Minister of State, Mr. Alvin Tan, Mr. Goh Soo Jin, Chief Executive Officer of Prime Movers Equity, Professor Tan Cho Chuan, Chairman of A-Star, and last but not least, Mr. So Ling Wan, Governing Board Member of NAMIC. Ladies and gentlemen, a round of applause. Now, with all our witnesses and signatories in place, we would now like to commence this partnership by inviting our representatives to sign on the MOU. And ladies and gentlemen, a round of applause for the partnership. May I invite NAMIC and IngTech's representative to raise the MOU for a picture together. All right, ladies and gentlemen, once again, a round of applause. Thank you. Thank you, Dato and Mr. Goh. We'd like to invite you to take a seat while Minister Dr. Ho and Prof. Tan please remain on stage. Now, next up, I'm pleased to announce a collaboration between Skills Future Singapore, the American Society of Mechanical Engineers, and the National Additive Manufacturing Innovation Cluster. Now, for this MOU, we'd like to invite our representatives from ASME and SSG to join Dr. Ho on stage. Now, firstly, on behalf of Executive Director and CEO of ASME, Tom Costabile, we have Mr. Peter Marino, Principal of Strategy and Special Projects. And representing Skills Future Singapore, we have the Director of SSG, Ms. Loh Gek Kim. And joining our signatories on stage, please welcome our witnesses, Mr. Fu Piao Cho, Group Director, Training Partners Group at SSG, Ms. Laura Baker, Deputy Senior Commercial Officer of the US Embassy in Singapore, Mr. Eric Ho, Head of Singapore ASME, and last but not least, Professor Reginald Tan, Governing Board Member of NAMIC. Ladies and gentlemen, another round of applause. And with that, we'd like to commence this collaboration by inviting our signatories to sign on the MOU. Now, with this MOU, the three parties will collaborate to review and authorize the National Additive Manufacturing Job Skills Accreditation Framework to mapping the existing continuous education training AM courses onto different proficiency levels for specific AM jobs and guide the development of new AM courses to plug existing skill gaps. And with that, we're done at the same time. So ladies and gentlemen, shall we give them a round of applause? And can I invite our signatories to raise your MOUs for a picture together. Thank you, ladies and gentlemen. Please take a seat while Minister Dr. Ho and Prof. Tan please still remain on stage. And of course, last but not least, for our final partnership formed today, we're happy to announce the launch of the Digital Design Innovation Center by the National Additive Manufacturing Innovation Cluster and Jaringan Semangat Sediaan Berhad. So join us on stage for the MOU signing ceremony. May I please invite Mr. Rosli bin Abdul Hamid, Managing Director of JSSB, to join Dr. Ho. Now, we also like to welcome our witnesses, Mr. Kong Wai Cheng, General Manager at GSSB, Mr. Azrul Hazimin bin Mohammed, Group Technical Authority of Petronas GTS, and Mr. David Toh, Governing Board Member of NAMIC. Now, this partnership between JSSB and NAMIC will leverage on DDIC's capabilities to help companies in the oil and gas sector to overcome the cost and knowledge barrier in adopting additive manufacturing solutions, especially in digital design and parts digitization. And so it is with great pleasure we'd like to bring forth this partnership with the signatories signing on the MOU. So ladies and gentlemen, a round of applause. Congratulations. I'd like to invite our signatories to please raise your MOU for a photo together. Thank you very much, gentlemen. Please take a seat. And ladies and gentlemen, another round of applause for our 4 partnerships and alliances. Very exciting things to look forward to. Now, I'd like to hold Dr. Ho and Minister on stage just for another minute or a half We'd like to invite the rest of the gentlemen to please take a seat. Minister and Dr. Ho, please remain on stage for just another minute. Now, at this juncture, we'd like to take the opportunity to thank Minister for taking time out of his busy schedule, out of Parliament and everything, to join us at this year's Global AM Summit. So for that, we'd like to invite Dr. Ho to present him with a token of appreciation. Ladies and gentlemen, a round of applause. Now, thank you, Minister. Thank you, Dr. Ho. And as we wrap up the opening ceremony, we'll now like to invite Minister to take his leave with our guests at the VVIP table for the ITAB booth and exhibition tour. Now, while that is happening, we'd like to invite everyone to please remain seated. And for those of us who are interested to visit the exhibitions at ITAB later, you will be able to do so by showing your GAMS pass, so please don't lose it. All right, it gets the entrance into the ITAB exhibition. So now, while Minister recce the site for us, we will bring things back to here in the hall and kickstart the summit portion of GAMS. So let us take a look at digital transformation with additive manufacturing for a sustainable future with founder and CEO of Movement Technology, Mr. Chi Teck Lee. Ladies and gentlemen, a round of applause.
Ladies and gentlemen, distinguished guests, and fellow innovators. It gives me great pleasure to be here today to speak to you on a topic that is closely intertwined with today's theme of digital transformation with additive manufacturing with sustainable future. Sorry, this doesn't quite work. Okay. I see. Okay, my name is Teck Lee, and I'm the founder and CEO of Movement Technologies. So we are a SME, a local-based SME that specializes in providing optic solutions to the industries. And we take pride in that we adopted the additive manufacturing and its deployment to serve the diverse needs of our customers for many, many years. And today, I would like to talk about the challenges and trends of additive manufacturing. Right, let's start with something provocative. It is a gimmick, nothing less than that. If it is really that good, I'll write my surname backward. Now, these were the exact words uttered by none other than Terry Goh in 2013. And nothing is more unsettling than hearing such words coming out from a veteran in a modern, traditional manufacturing, a company that manufactures more than 5 billion handheld devices over the last 15 years. It epitomized what I would call the single biggest challenges of additive manufacturing, coming from the optics of a traditional manufacturer. On a more subtle note, Dr. Chris Choupé made this comment. Most major corporations in the world have built really effective design and manufacturing processes around traditional manufacturing. It is hard to change momentum of big industry. And I think many of us can relate to this, right? Because if you have invested so much in traditional manufacturing and use this as an approach that is easily accessible, that's reliable, that is cost-effective, why do you need to reinvent the wheel? So today, despite additive manufacturing being door openers and making a lot of things possible, there are many limitations and challenges. And this is a list of challenges that I felt would be good to share. Of course, this is a non-exhaustive list, and I'm happy to walk through with you each and every one of these limitations in the next 20 minutes or so. Let's start with the low-hanging fruit. Materials limitation. Now, plastics and metals are probably the most common materials for 3D printing. Much needs to be done in expanding the choice of these materials. Traditional manufacturing can use a broader area of materials like ceramics, composites, alloys, each with its own distinct properties. And I can tell you for sure, because I am coming from the optics manufacturing, so we make tools, right, injection molding tools. Within the tool itself, I can count at least 7 to 8 types of materials, metals, right? Some would be heat conducting, some would be easy to machine, that will give you the best finishing, and there will be others that requires a certain level of structural integrity and so on and so forth. But these materials are missing from the equation with respect to additive manufacturing. And this is, in a way, limiting the traditional manufacturer's choice of materials. The performance and durability of 3D printed parts don't always match those of conventional manufactured parts. And that's easy to understand, right? Because 3D printing, after all, is a layering process. So you can expect that the final printed part would be anisotropic in terms of its physical and mechanical properties. All right, and the next thing, which is most important as a limitation, is the speed and scale. Production speed, as we all know, is somewhat limited for now. 3D printing is always viewed as excellent for prototyping and small batch production, but it struggles to compete with the traditional manufacturing with respect to large-scale production at a cost-effective price point. And case in point, if you look at this animation, right, the traditional method of using injection molding, where you could literally have multi-cavity tools from 2 to 4, all the way up to even 32 cavities, versus 3D printing, right? It is often sequential, piece by piece. And therefore, it is difficult for 3D printing or additive manufacturing to catch up pace with traditional manufacturing. Integrating 3D printing into manufacturing production also requires print speed to be improved significantly. For example, if you have a line and most of the processes in the line is using traditional manufacturing process, and you want to introduce 3D printing into any one of these processes, it is quite challenging because you don't want that 3D printing process, that particular process, right, to slow down the pace of the production along the line. Next on the list, cost of equipment and materials. High-end industrial-grade equipment remains prohibitively expensive, especially for small companies like us, right? Also, specialized material requires high-performance applications, can also be costly, and this, in a way, is limiting the technology's ability and competitiveness with respect to conventional manufacturing. Now, on this picture, these are two different equipment manufactured by the same equipment manufacturer. I will not name the equipment manufacturer. You probably can guess who it is. On the left-hand side would be an injection molding press, and on the right-hand side would be a 3D printer. And you can see that the cost, the process cost of making a 3D part, the similar 3D parts from these two processes are quite distinct, right? It is about 5 to 10 times more. And in terms of the equipment investment, it will be at least 3 to 4 times more. So this is actually a big hurdle for the adoption of additive manufacturing. Next on the list, of course, is quality control and consistency, and this is very, very important. As a manufacturer, we all know how important it is to be able to control your quality, to be able to communicate quality across your customers, your vendors, and so on and so forth. Ensuring consistent quality is a significant obstacle in 3D printing. Additive manufacturing processes can result in cracks, defects like porosity, micro cracks, surface roughness, and so on and so forth. Now, obviously, in traditional manufacturing, this is also the case. But in traditional manufacturing, you are familiar with the kind of defects that you get to see. And therefore, you could somehow do predictive countermeasures, right? With something like injection molding, you already have software that helps you do finite element analysis, failure analysis, and so on and so forth. And using something like mold flow will easily allow you to predict the potential issues and correct them even before you cut steel. But with 3D printing, this is not really the case. And it is still something that's evolving and will take time to mature. Traditional manufacturing methods have well-established quality control processes, whereas additive manufacturing is still developing standardized test protocol. And this is very important because if you cannot communicate this across clearly to your suppliers and customers, then it is going to be very challenging. Very important, intellectual properties and regulation. There is a growing concern about the intellectual property theft. Obviously, it is quite easy to copy files and kind of like share files. So digital files for 3D printing can be easily shared and modified, leading to unauthorized reproduction or alteration of products. And regulatory framework must keep pace, and this hasn't happened quite yet. But this is something that is very important, and for this industry to take off, this sector, this issue has to be resolved, especially for mission-critical sectors like healthcare, aviation, automotive, and so on and so forth. Now, this is important enough for me to put on a slide. We all need to know that copyright law protects original work of authorship, and this includes 3D printed objects designed using CAD software. Now, the creator of an original 3D model owns the copyright to the design by default, right? Giving him or her the exclusive rights to reproduce, distribute, create derivative works from their design. So registering an original design with Copyright Office strengthens the ability for enforcement. Okay. Now, unauthorized use can come in many ways. For example, selling of 3D printed copies without permission, distributing the CAD files so that others can print, and making adaptations of the original design to create derivative work. In a nutshell, existing copyright law does provide protection, but one must take proactive measure to exert rights over their intellectual property. So it's up to you to really protect your IPs. What about environmental impact? Well, although 3D printing has the potential to reduce waste, as you heard from the minister himself, the energy consumption remains very high. And when I say energy consumption, one must understand that it is not just the 3D printing process itself, right? Very often the 3D printed product also need post-processing, like milling, polishing, and so on and so forth. And this consumes energy. Many of the polymer used in the 3D printing are also not biodegradable and not reusable, right? Raising questions about their long-term sustainability. And in comparison, if you look at traditional method like injection molding, most of the materials used are thermoplastics, right? So they can be recycled. For example, the runners can be crushed, defective products can be crushed, and then you can mix them with virgin materials, and then you can recycle them. This is not so much the case with additive printing because the materials used are mainly UV curable, and therefore they are thermosets. They are used once and throw away, you know. The environmental impact of producing raw materials and post-production processes such as finishing and assembly must really be taken into consideration. So it's not just about the printing process. It's also about, you know, the finishing processes leading you to the final fit-for-use product. All right, now that we have tackled the challenges, it's beginning to feel that 3D printing is really something that has a lot of barriers before adoption takes off. But not to be disheartened, I think this is really a very exciting technology that has been embraced and will continue to be embraced. And there are very exciting future trends in this sector that is worth a mention. For example, advances in material science, improvement in print speed and scalability has taken off quite significantly. And of course, Customization is also very exciting, especially in the medical space, and on-demand manufacturing where everything can be done within the same location instead of having to worry about the logistics, the supply chain and so on and so forth. Using automation and integrating this with AI, this is also very exciting because despite the fact that you may have everything that is printed differently or sequentially, but AI and the use of automated vision inspection can really help to address that and make your product more consistent. Sustainability and circular economy, there's advances in this area as well. And of course, very exciting is that medical applications and bioprinting. I think this is probably one of the sectors that has really embraced 3D printing. And last but not least, the global supply chain disruption. So I'll take you through one by one. Now, researchers are working on expanding the range of materials compatible with 3D printing. And this includes bio-based, biodegradable resins, performance alloy, and so on and so forth, right? Significant advances in multi-materials printing, where materials of distinct properties can be printed in the same part or assembly, creating complex and functional products. And a very good example of this would be what we call, in our industry at least, a process called two-photon polymerization. Now, two-photon polymerization is a 3D additive manufacturing process that is of a very high precision, right? But it is limited to very small parts in the micro or sub-micron dimensions. And you can see on the top, it's a lens stack that is designed, and then you can use two-photon polymerization with 2 different materials or 3 different materials to print a stack of optics. And this is just about 500 microns in diameter, right? And such optics are widely used in things like microendoscope. But two-photon polymerization is not limited to just optics, right? You can also use it to print, let's say, for example, the micro needles, and stuff like that, which is very challenging for traditional manufacturing to take hold of and to produce. All right, this is important because without overcoming this hurdle, it's going to be very challenging for adoption of additive manufacturing. The quest for faster production speed will continue to be a major area in innovation. New technologies like continuous liquid interface production, CLIP, and high-speed sintering are emerging to address the speed issue with the potential to bring additive manufacturing closer to traditional production capabilities. Hybrid manufacturing combining additive and subtractive processes is likely to gain traction, right? Offering benefits to both 3D printing and traditional machining. And none of this is so true as, for example, making an injection tool. And this is something that we struggle with every day, right? In this tool, we have many different components, up to, let's say, hundreds of components, and they use different kinds of materials, different kinds of alloy, right? And most of these components are made using traditional processes like CNC milling, EDM, wire cut, lapping machines, and so on and so forth. But finally, you will then need to assemble them together and allow this to be mounted on a machine for injection molding. But there are pockets of areas where 3D printing can really contribute. To make a tool like this involves making also a cooling channel, right? This cooling channel is important because you need to cool down the process using a coolant. And the traditional method of making this kind of insert is to essentially drill horizontal holes across the metal inserts and plugging the junctions where it matters most so that you can form a continuous loop. But this is not an ideal solution because the cooling is forced to make to move in a very structured way without being very effective in terms of the cooling. Now, this can now be replaced with what we call 3D printed conformal cooling, where the cooling channels are printed in such a way that it conforms to the geometry of the insert. And when this happens, it allows for more optimized cooling, as you can see from these thermograms. So this is one example of how hybrid manufacturing can combine additive and subtractive manufacturing to make sense of the manufacturing and to offer a better solution to our customers. taking you down memory lane. This is the first 3D printed part produced by Mr. Chuck Hull in 1983. And this is made using a prototype printer that he developed himself. You can see this on the right-hand side. And this piece here, measuring slightly more than an inch, took a few months to take shape. Okay, you may laugh at this now, but today this same part can be produced within 10 minutes or within minutes with better finishing and structural integrity. So this goes to show that 3D printing has really come a long way. Customizable and on-demand manufacturing. Now, additive manufacturing is well positioned to lead a shift towards greater customization, right? As you can see from the earlier presentation. And this is none more obvious than in medical applications. Products can be tailored to specific needs of individuals or businesses, right? Whether that's a medical implant, personalized consumer products, or spare parts made on demand. So you can see some of the examples here would be 3D printed orthotics, or even printed frames for your spectacles and eyeglasses. And this is real because Hoya, the famous Japanese optics company, they have actually launched a vending machine that print precisely what is shown here, the frame that's suited to your face shape, your geometry, and so on and so forth. And it is something that showcases the customization of 3D printing and the advantages that it brings forth. This trend could also lead to decentralized manufacturing where products are printed locally, reducing the need for global supply chain and, of course, inventory cost. And here are more examples of suitable products that would take advantage of 3D printing, from dentures to shoes to keyboards with optimized ergonomics, 3D printed titanium hips and socket. Automation, also mentioned by the ministers, and how we can integrate AI into the equation. Automation will enable a more efficient and less labor-intensive production. Artificial intelligence and machine learning will further enhance 3D printing and by optimizing designs, predicting material performance, and automating quality control. And I want to point you out to this animation here. This is an actual product or printer that we are developing. And what you see here is, on the left-hand side, it's a magazine that's loaded with injection molded panel. But what the printer does is that it prints another layer of light blocking ink on one of the slopes. And then there's a camera that's staring down at the printing. And because this is done with inkjet printing, nozzles get clogged from time to time. And when the nozzles get clogged, you see the part quality varies. So what the AI does here is that it looks at a part and it determines where the printing is not to its mark because some nozzles are clogged, and it alters the algorithm by switching to other nozzles that were not clogged. And by doing so, we could actually infuse AI into making the process more productive and the quality more consistent. Okay, so I think this is an example of how we can use AI or machine learning, whichever way you want to call it, to help create processes which are more reliable. So AI-driven design tools like this could expand the boundaries of what is possible, allowing for the creation of highly complex, optimized structures that will be impossible to produce with traditional method. And let me show you the real product. Okay, this is a panel that I spoke about. This is a prototype version. Unfortunately, the video is not playing, but that's fine. What you can see here is a panel that we printed, that we molded, but only on one side of the Fresnel. So this is made by Fresnel, right? So only on one side of the Fresnel is printed with a dark ink that blocks the light. And why is this important? Because this panel is used for holographic projection. And at certain sites, on one of the sites, you do not want the glare of the sun to be transferred to the eye, rendering the vision of the holograms more challenging, right? So this is exactly what an AI-enabled 3D printer would be able to achieve. Sustainability and circular economy. Now, as the global focus on sustainability intensifies, additive manufacturing has has the potentials to contribute to a more circular economy. It's a good news that researchers are now already exploring ways to recycle 3D printed products and reduce energy consumption during the printing process. And this is very important because if you continue to generate waste and you cannot recycle or reuse them, then this technology is not going to be very good for our environment. Additionally, new materials like biopolymers and biocomposites could help reduce the environmental footprint of 3D printing. So hopefully more work gets done in this area and the world can be a little bit more sustainable as we embrace additive manufacturing. Medical applications and bioprinting, this is probably one of the very exciting areas. In the healthcare field, additive manufacturing is poised to make revolutionary advances. I've spoken about this earlier, customized prosthetics, dental implants, bioprinting of tissues. It's all been developed on the horizon. Bioprinting will one day, hopefully, give rise to living tissue printing, potentially the printing of even functional organs. And of course, global supply chain, right? Additive manufacturing will enable the localized production, thereby reducing the need for large-scale shipping, storage, and of products. And if you look at this animation, right, it really takes a lot of work to see how parts can be shipped or transferred from point A to point B. There's really a lot of work, right? And if we could do away this through 3D printing, it saves on a lot of time, resources, and of course money. So hopefully companies can adopt a print-on-demand model, allowing them to produce goods as they are needed, right? So it's like a JIT kind of arrangement. And obviously this could significantly reduce the lead time and transportation cost. And we see how important this is during the COVID days where the entire supply chain was kind of like disrupted. Okay, here's a table comparing the pros and cons of additive manufacturing versus traditional manufacturing. I will not go into the detail in the interest of time, but it is something that goes to show that 3D printing is making advances and it's going to be a very exciting technology to embrace and adopt in the years to come. All right, I would like to come back to this statement made by Terry Goh. It is a gimmick, and this statement was made in 2013. Fast forward to today. Foxconn and Tridactive partner to develop new metal jet 3D printer. This was announced in 2022. And it goes to show how much 3D printing has advanced to the point that it can change the skeptic minds. Right? And this is good news for 3D printing industry, for Foxconn, a large traditional manufacturer, to embrace this. In closing, the challenges of additive manufacturing are not insignificant. Material limitations, production speed, cost, regulatory issues present hurdles to be overcome. However, the future trends in this field are incredibly promising. I think every one of us in this room recognize that. Otherwise, we won't be here. Advances in material science, the integration of AI and automation, sustainable practices, and the expanding medical applications of 3D printing are just a few of the factors that will drive this industry forward. Well, not just the medical industry, but a lot more other industries, right? Even for us, an optics company, where it is traditionally very difficult to make optics through 3D printing, we are also pioneering in that space. Unfortunately, that's for another day. Additive manufacturing is not just changing how we make things, it's changing how we think about making things, right? So before we even start planning and embarking on the manufacturing, we have to think, we have to plan, we have to figure out the best way, the most cost-effective approach to getting the products made. As we address the challenges, I'm confident that we will continue to unlock the full potentials of this technology, leading to a future where 3D printing is not the exception, but the norm. Last but not least, I would like to invite all innovators to make my dream machine. Okay, hopefully one that can print different kinds of traditional heritage food, I call it. Thank you very much for your attention.
Thank you, Teck Lee. Thank you. So if anybody can make that kind of machine, please do let me know as well. I'm also interested in getting one. And of course, with that, we set the tone of the summit. And over the next 2 days, we will take a look at exactly what Teck Lee has mentioned, the challenges, the promising opportunities, and of course, how we're going to move ahead as an entire AMS sector together. Now, of course, before we dive into our first track of today, we'd like to invite everyone for a quick 25-minute tea break just right outside. So before coming back here at 10:45, where we will dive into the first track, Breaking Barriers, looking at business strategies in AM for today's challenge. So with that, please enjoy a tea break, and we'll see you back here at 10:45.